Hello folks, I'm Natalie M.
And this is Emily G. Welcome back to another award-winning video.
This is section 10.5, Graphs of Trig Functions, part 1b.
Thank you, ladies, for the guest introduction. Now let's get back to the trigonometry here. Okay, so we left off on page 2 of the notes, and I just want to tidy up a few things here before we do anything new. For amplitude, the absolute value of A, I said that's max minus min over 2, but I neglected to actually draw in the absolute value symbol there. We'll see a couple examples where A, if you look up here, doesn't show an absolute value symbol. A could be negative, which if that value is negative, it indicates that the graph is a reflection across the x-axis of the positive version of A. But amplitude is a distance, so we're always going to report it as a positive value. One other thing that I should mention here is that the phase shift is really a horizontal shift. And in the last video I talked about the transformation equation up here and how this coefficient A gives us vertical stretch, B gives us horizontal stretch, and then H and K are horizontal and vertical shift respectively. Okay, let's actually do an example problem here. So number 3 says rewrite f of x equals 2 sine of pi minus 2x all minus 1 in s of x form. Then identify the functions period, phase shift, and vertical shift. Okay, so we're going to go ahead and start with, I'm going to just write the s of x form here. All right, let's go ahead and get started on question number 3. It says rewrite f of x equals 2 times the sine of pi minus 2x all minus 1 in s of x form. So I'm going to try and make this function look like this. And I'm going to start by rearranging what the argument of the trig function. So that's going to become f of x equals 2 times the sine of negative 2x plus pi all minus 1. Okay, the next thing I need to do is get rid of that negative sign in there in front of the x. I need to make omega greater than 0. So I'm going to make a quick note over here. We need to make omega greater than 0. The reason why is up here, because these transformation equations are for omega greater than 0. So I'm going to do that by factoring out a negative 1. 2 times the sine of negative times 2x minus pi, still all minus 1. Okay, so what I did there was, think of it as factor out a negative 1. Now the next thing I'm going to do is kind of tricky. I'm going to rewrite that as f of x equals negative 2 times the sine of 2x minus pi minus 1. Boy, I hope that you guys recognize where that comes from. That's one of our even and odd identities. Remember, sine is an odd function, so the sine of negative theta is equal to the opposite of sine theta. And that might be a stretch for some of you to remember that. It's back a lesson or two ago. But that's how I'm able to get rid of that negative sign from inside the parentheses. And now I have something that is written in s of x form. Let's take a look at each of these components. My amplitude is 2. My omega is 2. My phase or phi is pi. And my b, my vertical offset or vertical shift, is negative 1. Notice that the amplitude I'm saying is 2, and there's a negative sign out in front of that. That indicates a reflection across the x-axis, but we weren't asked to graph this one, so we don't really need to worry about that. Okay, so let's go back and address all the things we were asked to do. We've got omega equals 2. We've got phi equals negative pi. Why is it negative pi? Because this is omega x plus phi, so that has to be a negative pi. From these two values, I can, and this negative 1 here, I can now determine all the things I was asked to do. First thing we'll look at is the period of the function. Boy, if only we could spell the word period. Okay, so period of the function is going to be equal to, period equals 2 pi over omega. So now I'll go ahead and substitute in what I know. This is going to be 2 pi over 2, which just equals pi. So the period of this function is pi. The period of the regular sine function, or just sine of x, is 2 pi. So this one is horizontally compressed compared to the regular sine function. Folks, I hate to do this. I'm still not happy with the way that looks. Let's go ahead and fix it. Much better. Now you're getting what you paid for. Okay, let's look at phase shift now. The phase shift is equal to negative phi over omega. So that will be negative, or the opposite of phi, which is already negative pi, divided by omega, which is 2. The opposite of negative pi is pi, all divided by 2. So the phase shift there is pi over 2. What does that mean? That means when you graph this function, it will be shifted pi over 2 units to the right. A phase shift is a horizontal shift. Pi over 2 units to the right. Last but not least, let's take a look at vertical shift. Oh my goodness, folks, I need a spell checker. Our vertical shift is equal to b, and that equals negative 1. So the midline of this function is not at y equals 0, it will be at y equals negative 1. It will be shifted down 1 unit. Well, that's it for example 3. Let's move on to example 4. Okay, so in example 4, we're asked to find a cosine function that matches the graph of y equals f of x, and here is one cycle or one period of that graph. So this is a little bit different than question 3. In question 3, we were given a function and asked to analyze it so that we could see what its graph looked like in terms of numbers. And those numbers that describe the graph are those things here, the period, phase shift, and vertical shift. Also the amplitude. We did talk about that. That question should be more complete and ask for the amplitude as well. Anyway, in question 4, we are given the graph of a cosine function and asked to come up with the function. So we're gonna analyze this in a couple different pieces. We're gonna start by looking at this distance right here. So from here to here, that distance is known as the period. So that is the period of this function, one complete cycle. And that from negative 1 to positive 5, that's 6 units. So the period of this function is 6. So from that, if we go back and look at our formulas up top, we have the period of a trig function is equal to 2 pi over omega. If I rearrange this equation, I can get omega equals 2 pi over 6, which is just pi over 3. So we know our we know this value is called our angular frequency. That's going to tell us our horizontal compression, and it is related to the period of the function. The next thing we can do is look at the amplitude of our function. In order to talk about the amplitude, I really need to look at the max value, which is 5/2, and the min value, which is negative 3/2. Remember, the absolute value of A, or our amplitude, is equal to max minus min over 2. My max is 5/2. My min is -3/2. I have to divide that by 2. 5 minus -3 is 8. That's 5 plus 3, that's 8. 8 divided by 2 is 4. And then 4 divided by 2 is 2. So our amplitude is 2. Next, we'll talk about the baseline of this function, or the midline. The baseline of this function is our vertical shift, and that equals max plus min divided by 2. It's the average of those two, not the distance between those two. So 5/2 plus -3/2, all divided by 2. 5/2 minus 3/2 is 2/2, which is the same as 1, and 1 divided by 2 is 1/2. Now that should make intuitive sense when you look at the fact that this function has a midline right there at y equals 1/2. Okay. Next thing we'll do is look at phase shift. Phase shift is equal to -phi over omega. Well, in order to figure out phase shift, I need to go back and look at the graph. By the way, I don't like the way I drew that phi, so I'm going to fix it for you. That's better. So let's go back and look at the graph. If this were the cosine function, it would start at 0, 1. Well, we have an amplitude of 2, so it would really be 0, 2, and then it would be shifted up a half unit to 2.5 or 5/2. But we're starting left of that. So this distance right here, and I'm going to go ahead and kind of draw this marker in here. This distance from here to here represents our phase shift. So that's a -1 right there, and that is our phase shift. So we are shifted left 1 unit. And now we have to see how that turns into the value, how the values of phi and omega work to get us that phase shift of -1. So we were told already, or I shouldn't say we were told, we solved for omega and we got pi over 3. So we have -phi divided by pi over 3 has to equal -1 because that's my phase shift. So any number divided by pi over 3 that equals -1, well, that number has to be pi over 3. See if I can do a better job explaining that, folks. Phi has to be pi over 3 because pi over 3 divided by pi over 3 is 1. The opposite of pi over 3 divided by pi over 3 is -1. So we now have all the different values we need to write the cosine function for this graph. Remember, the function is going to look like this. Y equals capital A times the cosine of omega x plus phi all plus b. So let's substitute in the values we know. Y equals 2 times the cosine of pi over 3 times x plus pi over 3 all plus 1/2. And that's the final answer there. Find a cosine function that matches the graph. We've done that. But there's a part 2 here. It says then find a sine function that matches the graph of y equals f of x. Uh-oh, so I have to take all this work I did and I have to start it over? Could that really be what we have to do to convert to sine? Absolutely not. That would be absurd. Because we already know that there's a cofunction identity between cosine and sine. Remember, the cosine of theta is equal to the sine of its complement, pi over 2 minus theta. So all I have to do is take this stuff in here, subtract it from pi over 2, and I'm going to have an equivalent function, an equivalent sine function. So let me write that out for you. Y equals 2 times the sine of pi over 2 minus all the stuff inside the parentheses here, which is pi over 3 times x plus pi over 3. And don't forget about the plus 1/2 out here at the back end. Now I'm probably not going to leave it like that because that's kind of messy. So let's do some simplifying inside the parentheses. I'm going to have 2 times the sine of, well, let's see, that's going to be negative pi over 3 times x. And then I have pi over 2 minus pi over 3. Let's see, pi over 2 minus pi over 3 is equal to pi over 6. And I still have my plus 1/2. Now if I want to have that in the correct form, I need to get rid of this negative sign right here. And I'm going to go ahead and remind you that the sine of negative theta equals negative sine theta. Oh, folks, you deserve better. That didn't fit there. Hold on a second. Let me try that again. The sine of negative theta equals negative sine of theta. There we go. Okay. So I rewrite this with that, using that odd function identity, negative 2 times the sine of pi over 3 times x minus pi over 6. Why minus pi over 6? Remember, I factored out a negative 1 from here and then used this identity to rewrite it as negative 2 times the sine of pi over 3x minus pi over 6. Don't forget about the plus 1/2. There we go. There we have it. Now we're done. This is our final answer. And what I would encourage you to do if you get a question like this is graph it. So you've got fancy graphing calculators. Go ahead and graph it and make sure it hits all of those points. Max and min plus midline of y equals 1/2. So let's actually see if this worked. Let's graph this bad boy and see if it hits the points that we expect it to. I'm going to go to my good friend here, GeoGebra. And let me pull that down a little bit so I can see each of those two functions. We'll go ahead and type the function in. The first one we had was y equals 2 times the cosine of pi over 3 times x plus pi over 3 all plus 1/2. Grip it and rip it. OMG, folks, look at that. Those were the points we were given, and we have come up with a function that hits all those points. I'm really excited, but wait, there's more. I want to plug this one in too to see if actually all that work we did is right. If I plug this function in, what I should end up with is another graph that's directly on top of this one. And then I'll feel confident that all of that hard work we did was worthwhile. So I have negative 2 times the sine of pi over 3 times x minus pi over 6 plus 1/2. Grip it and rip it, and look at that. We've got the same graph superimposed over the original graph. So I am so confident now in this answer that, I don't know, maybe I'm going to take myself out to dinner. I'm so fired up about this that might be my reward for tonight. Or no, wait a minute. I'm going to go to the toolbox. I hear there's some pretty cool stuff in there. Maybe even get a plastic dinosaur. All right, that's enough with question 4. Let's go ahead and move on to question 5. Okay, folks, I know the video is getting long, and I appreciate your patience. We're going to move on to the final example in this lesson. It says graph one cycle of the following function and state its period, amplitude, phase shift, and vertical shift. For this question, I'm going to go ahead and use the alternate form of the sine function that I talked about earlier, and it's this version right here. F of x equals a times the sine of omega times x plus the phase shift phi over omega, all plus b. Well, fortunately for this question, our plus b is plus 0, because I can see we got nothing tacked onto the outside there. But for everything else, we're going to have to do a little rearranging to get the function in this form. So let's go ahead and get started with that. I have f of x equals 4 times the sine of, I'm going to factor out this negative 2 pi, because that's the coefficient on the x term there, negative 2 pi times x. Well, if I factor out a negative 2 pi from this expression, perhaps I should show that below. So if I have negative 2 pi x plus pi, and I factor out a negative 2 times pi, I'm going to be left with x minus 1/2. Why x minus 1/2? Because negative 2 pi times negative 1/2 is just regular pi, which is what I had here. Okay, so this is negative 2 pi times x minus, whoa, jumping around, x minus 1/2 plus 0. All right, so this is, my omega value is negative here. So I'd like to force that to be positive, because that's just a standard operating procedure. And I've done this a couple times already. Hopefully you recognize that to turn this into a positive value, I can just take the negative, I can take the opposite of what's outside here, the opposite coefficient out front. So this will be negative 4 times the sine of 2 pi times the quantity x minus 1/2 plus 0. All right, I'm ready to start breaking this thing down. Let's talk about the different pieces, parts here. We have an amplitude of 4. Because we have a negative sign, so that negative sign indicates a reflection across the x-axis. And we then go over here. This represents our omega. Omega equals 2 pi. This right here is going to help us out with our phase shift. Phase shift, if I could spell phase. Folks, apparently spelling is not a requirement to be a math teacher. Phase shift, well, if that's x minus 1/2, if you recall from all the work we did with transformations before, that's going to shift our function to the right 1/2. So we're going to be shifted right 1/2 a unit. And then let's go ahead and talk about the period of our function. So the period of our function equals 2 pi over omega. And because omega is 2 pi, we have 2 pi over 2 pi, which just equals plain old 1. Okay, so we have a period of 1, we have a phase shift of right 1/2 unit, and we have an amplitude of 4, but it's reflected across the x-axis. So if we were to start graphing just the regular old sine function, we know we would start at 0, 0, and we would have a period of 2 pi, something like that, and we would have an amplitude of 1. And I'm just sketching that in there for reference, but because we're not going to use that. What we are going to do is look at all the different pieces, parts here, and see how they turn into a graph. First of all, my phase shift is right 1/2 a unit. So I'm going to go ahead and define this point right here as 1/2. So each of these tick marks is a quarter. If that's 1/2, then this guy here is 1, and this guy here would be 3/2. Now my period is 1. So I need to complete one whole cycle of this function from 1/2 to 3/2 because that is 1. 1/2 plus 1 is 3/2. So I need to fit one whole cycle of this graph into that region there. I know that the midpoint between the start and end of the period, I'm going to cross back across the midline. Remember, folks, the midline or the baseline is going to be y equals 0 or the x-axis. Okay, so what now? I have a amplitude of 4. So this is going to go 1, 2, 3, 4. It's going to go all the way up to 4. And it's going to go down 1, 2, 3, down to -4. And because I have a baseline of 0, I know I'm going to go all the way up to 4 and all the way down to -4. But instead of the sine function starting and going up, this one's going to start from this point here, x equals 1/2. It's going to start going down because of that reflection across the y-axis. So halfway between here and here, I'm going to hit -4. Halfway between 1 and 3/2, I'm going to hit +4. Graph of this function is going to look just like that. Okay, folks, notice I did that without a calculator. I just knew a few things about the cosine function and how omega, phi, period, baseline, all of these things work together to give us that graph. Folks, that's it for this lesson. Hey, this video is really long, but I do appreciate your time and attention. Please don't forget, ask me questions if you have any in class. Thank you.